This video is about quadratic word problems, so pay attention and be prepared to bring questions to class tomorrow if you have any questions. Alright, the first problem is a motorboat takes 2 hours to travel 8 miles downstream and 4 miles back on a river that is flowing at a rate of 2 miles per hour. Find the rate of the boat in still water. Hopefully you recognize this as a distance equals rate times time problem. So I'm going to go ahead and fill in this chart with as much as I know. I know that he's going downstream as well as upstream. It says that he traveled 8 miles downstream and 4 miles back, so that would be 4 miles upstream. A river is flowing at a rate of 2 miles per hour. I want to know the rate of the boat in still water. So I'm going to say x is the rate in still water. If I'm going downstream, that's always the that's always the rate in still water plus the current. Because if you're going downstream, you're going with the water, so it's going to push you a little faster than if you were just in still water. Upstream would be the still water minus the current, because you're going to go a little slower. The water's pushing against you this time, so you're going to go slower than if the water was just still. Alright, so the rate downstream is still water plus the current, which in this case is 2 miles per hour. Upstream is x minus 2. Remember to find the time. Time is the distance divided by the rate. So in this case it would be 8 divided by x plus 2. Here would be 4 divided by x minus 2. It tells me that the motorboat takes 2 hours to travel this distance. So that's downstream plus upstream equals 2 hours. I need to multiply by the denominators to get rid of them. Whatever I do to one side, I have to do to the other side. And then distribute. I'm going to keep distributing and then combine like terms. Since this is a quadratic, I'm going to try factoring. So I'm going to first get it equal to 0. So I have 2x squared minus 12x equals 0. The negative 16 plus 8 will be negative 8 on the left side. If I try to add 8 to both sides, they'll reduce. They'll cancel out. So I have 0 equals 2x times x minus 6. That means my two possible answers are x equals 0 or x equals 6. If x equals 0, that means my rate downstream was 2 miles per hour, and my rate upstream would be a negative 2 miles per hour. I can't travel negative 2 miles per hour, so that's out. So my answer is just 6. It says find the rate of the boat in still water. I've solved for x, and it is 6 miles per hour. Moving on, I have a small plane travels at a speed of 200 miles per hour in still air, so that means with no wind. Flying with a tailwind, so that means with the wind. The tailwind means the wind is blowing from your tail, so it's going with you. The plane is clocked over a distance of 960 miles. Flying with a headwind, it takes 2 hours more time to complete the return trip. Headwind means the wind is going against you, so it's pushing you back. So this again is distance equals rate times time. I have with the wind and against the wind. With the wind, the plane traveled 960 miles. Against the wind, it says completing the trip, so that means he went the same distance. The rates are just like the water. If I'm going with the wind, that's still plus the current, or in this case it's the wind. against is going to be still minus the wind. In this case, I need to know what is the wind velocity. Another word for velocity is speed. So that's what I'm trying to figure out. So I'm going to say W is my wind speed. If I'm traveling with the wind, it's how fast it can go in still air. So that would be 200 plus the wind and 200 minus the wind. Time is still distance divided by the rate. And it tells me flying with a headwind, so flying against the wind, takes 2 hours more than with the wind. So I'm going to rewrite this so it's 960 over 200 minus W equals 2 plus 960 divided by 200 plus W. And that makes sense. Versus the wind, so flying against the wind, it would have to take longer because you're going at a slower speed. So it has to take longer to go the same distance. I'm going to use the same technique of getting rid of the denominators by multiplying by the common denominator. On both sides. Okay, so I'm going to distribute here, so I've got 960 times 200 plus W, 2 times 20. Okay, distribute. Actually, I'm going to distribute in here first. So I need to know what's 960 times 200. So 192,000. Keep distributing. Now I'm going to combine like terms and get it equal to 0. So I'm going to subtract 192,000. So those are gone. I'm going to subtract the 960 W. So now I have 0 equals negative 2W squared minus 960 times 2, 1920, plus 80,000. I'm going to factor out the greatest common factor to make the numbers a little smaller. So now I need to know what are the things that multiply to negative 40,000 and add up to 960. I'm going to try 40,000 divided by 400. Not quite. 40,000 divided by 45. Nope. So 40 and 1,000 will work. So it'll be a positive 1,000 and a negative 40. So that means that either W plus 1,000 equals 0, in which case W equals negative 1,000, or W minus 40 equals 0, in which case W equals 40. Since W stands for the wind speed, The wind speed cannot be negative 1,000, so it has to be 40 miles per hour. Okay, Lisa can travel 228 miles in the same time that Kim travels 168 miles. If Lisa's speed is 15 miles per hour faster than Kim's, find their rates. So yet another distance equals rate times time. So I have Lisa, and I have Kim. Lisa travels 228 miles. Kim travels 168 miles. Lisa's speed is 15 miles per hour faster than Kim's. So it's 15 miles per hour more than Kim's. So K is Kim's speed. It tells me that it's the same time, so that means these two are equal. So 228 over 15 plus K equals 168 over K. I'm going to get rid of the denominators by multiplying by the common denominator. So 228K equals 168 times 15 plus 168K. Subtract the 168 from both sides. Divided by 60. So K equals 42 miles per hour. So Kim was traveling at 42 miles per hour, and Lisa was traveling at 42 plus 15, which is 57 miles per hour. Those were their speeds.